This is our beginning lesson into establishing an identity. I'm going to do just an example for you. You can write it in your notes, but you don't have to. It's just an example of what it is, what it means to establish an identity. What you're going to do is going to be given an equation like this. And your goal is to make one side look like the other side. About 90% of the time, we work on the left side and make it look like the right side. Not all the time. Every once in a while, it's easier to work on the right side. But in this case, I'm going to work on the left side, and I'm going to continue to do things to the left side until it looks like the right side to show that actually the left side of this equation actually does equal the right side, which right now it's hard to believe. They look very different. I could plug a radian value or a degree in for theta and show that one side equals the other, but we're going to use our identities. So you're going to want to keep that identity sheet out you made in the last video. Keep it close by to look at as we go through this example. As we go through this one, probably be confusing at first, but just kind of follow along as best you can, and then we'll get you some tactics. We're going to go through 5 tactics that will be helpful for you so that you can begin to do this by yourself. Okay, the first thing I'm going to do is I notice that I've got 2 fractions that I'm supposed to add together. And we all know that the rule for adding fractions is to have common denominators. Well, I could choose the denominator of sine theta and 1 plus cosine theta, but I have a better idea. Watch this. What we're going to do is take our sine theta over 1 plus cosine theta, and we're going to multiply it by the conjugate of the denominator. What is the conjugate of 1 plus cosine theta? 1 minus cosine theta. And of course, if I multiply the bottom, I have to multiply the top. 1 minus cosine theta. I'm going to put some parentheses over here so you make sure that you understand you have to FOIL that when you multiply. Plus 1 plus, I'm not going to do anything to this right now. And I'm in the habit of actually not writing the right side of that the whole time. I'll come back and write the right side later when I have worked the left side all the way down. So as we do this, I don't really know if I'm going to need to distribute the numerator or not. So I'm not going to right now. I might want to come back and distribute the sign. But I am going to FOIL the bottom. When I FOIL conjugates, remember we get 1, and then it would be minus cosine theta and plus cosine theta for the outsides and the insides. And the last would be minus cosine squared theta. And I'm not going to do anything to the second fraction at the moment. Now, I know you're thinking, why in the world would you do that? Well, watch and let's see what will happen here. So we get sine theta 1 minus cosine theta over, these two are going to cancel, right? That's why we love conjugates. So it's 1 minus cosine squared theta plus, make my pen a little thinner here, plus 1 plus cosine theta over sine theta. Now, look at your identity sheet. Look right here. Look right here. Check your identity sheet. Do you see an equivalent value that we can exchange for that 1 minus cosine squared theta? 1 minus cosine squared theta is equivalent to sine squared theta. Do you see that? Whoops, didn't work out too well. So on the denominator here, instead of writing 1 minus cosine squared theta, I'm going to write sine squared theta. Hey, we're getting closer to having a common denominator. Now, I have a choice. I could put a sine squared theta right here. I could multiply the top and bottom by sine theta. I could do that, and then I'd have a common denominator, but I don't want to do that. Let me show you why. Look over here. Do you see how I have in the numerator and denominator a sine theta? Connected by multiplication, so it's okay to reduce that. So we're going to actually reduce away one sine theta. So I'm going to cancel this sine theta with one of those, so it becomes not squared anymore. Okay, so we end up with 1 minus cosine theta over sine theta plus 1 plus cosine theta over sine theta. Well, that's kind of nice. Now I've got common denominators, so we're allowed to add the numerators. So we get 1 minus cosine theta plus 1 plus cosine theta all over my common denominator of sine. Well, you can see this working out now, can't you? The 1 plus 1 is 2, but the cosine thetas cancel out, right? This is a minus cosine theta with a plus cosine theta, so that's gone. So we end up with 2 over sine theta. Now, remember, I'm looking for this to equal, let's go back up to the top. What were we looking for it to equal? 2 cosecant theta. I'm looking for this to be 2 cosecant theta. Well, how am I supposed to get 2 over sine theta to equal 2 cosecant theta? Well, rewrite it like this. Do you agree that this is the same? That's equivalent to 2 over sine theta is 2 times 1 over sine theta. Look at your identity sheet at the top under the ratios part. Do you see a ratio equivalent to 1 over sine theta? That would be cosecant. The reciprocal of sine is cosecant. So it's 2 times cosecant theta. Whoops, I didn't write that, but it didn't come out right. Which is what we're looking for. And so we put these 3 dots. The 3 dots mean therefore. Therefore, 2 cosecant theta equals 2 cosecant theta. And you have proved your identity. You started out with this example, and all of this work led to the fact that, yes, one side does equal the other. So I know that's probably overwhelming to think you're going to need to do that by yourself. So let's give you some tactics. Let me give you some ideas of things to work with. Okay, number 1. This is in your book, by the way. Here, let me write and tell you where this is. This is the first part of your homework. The first part of your homework is to do page 471, numbers 9 through 18. And here's what I'm going to do. I'm going to actually do the odd ones for you, and then you can do the even ones for your homework. So let's do number 9. This is number 9, but I'm going to use number 9 to actually show you about tactic number 1. Let's write tactic number 1. And the tactic we have here is switch to sine and cosine. A lot of times it's easier to simplify your identities if they're in sine and cosine. So we'll take whatever they give us and switch it to sine and cosine. So we're going to use number 9 to demonstrate this, and then you'll do number 10 by yourself. Number 9 says tangent theta times cosecant theta. So the idea here is, the tactic is, let's switch this to sine and cosine, and then something might happen. We might be able to reduce. So look at your ratios part. Look in the ratios. Look at tangent theta. Can't tangent theta be written as sine theta over cosine theta? And then what can cosecant theta, can you find one that switches out for that? We can its reciprocal is 1 over sine theta. Now you see what happens? the sine theta cancels the sine theta, so I get 1 over cosine theta. Well, let's look. What can I switch that to? 1 over cosine theta is equal to its reciprocal, which is secant theta. So we could have started out this identity by saying prove that tangent theta times cosecant theta equals secant theta, and we'd have been able to prove that using this. So right now on these tactics, we actually don't have a right side. We don't have an equation. We just have an expression. We're simplifying. But later, it'll actually look like this right here, and you'll prove the identity, and this is the method you'll use. So tactic number 1, make sure you have this in your notes, is switch to sine and cosine. Now, you might want to leave a space in your note right now to go ahead and do number 10. You can pause the video and do number 10 if you'd like. Otherwise, I'm going to move on to number 11, which is going to demonstrate tactic number 2 for us. Tactic number 2 is to multiply. Now, there's some kind of side notes to tactic number 2. The side notes are, whoops, didn't work. Some ways that you multiply it might be to FOIL, which we know is just really distributing. Sometimes you're just distributing a monomial. And another time when you multiply, you're actually going to multiply by, like we did in the example, by the multiply by the conjugate. So I think, let's see what we're doing now. Let's do number 11. Number 11 says, number 11 is cosine theta over 1 minus sine theta. Times 1 plus sine theta over 1 plus sine theta. Okay, so this is a lot like the example we did earlier, but we're using sine this time. So the numerator, we're just going to distribute, right? We have cosine theta times 1 plus sine theta. And as you remember, make sure you remember when you multiply, you don't have to have common denominators. So we're allowed to go ahead and multiply this. So I'm just going to write it here as multiplication. Okay, so we really haven't done anything except for write them as one fraction instead of 2. So now as we distribute, we'll distribute the monomial term, which is going to be cosine theta plus sine theta cosine theta over, now we're going to FOIL the conjugates, 1 minus sine theta plus sine theta. Hopefully, actually, after this time, you shouldn't have to be writing that part at all. In fact, let's just go ahead and erase it. Let's pretend we didn't write that part. We know on conjugates that the middle terms are going to cancel each other out. So let's just write the first, which is 1 times 1, minus sine squared theta. Okay, so now from this point, you've really accomplished your goal, which is multiply. But let's go ahead and see if we can simplify this some more. Check your identity sheet. 1 minus sine squared theta is going to become cosine squared theta. And it looks now that I probably shouldn't have distributed the word cosine. So let's factor it back out. Let's leave cosine theta over 1 plus sine theta. Now you can tell, just like the opening, the cosine cancels with one of the cosines. So we get 1 plus sine theta all over cosine theta. And for now, this is as simple as we can get it. Simple as we can get it. And so that is your practice at tactic number 2, which is multiply. The next video will give you tactic number, well, actually, I think let's go ahead and do tactic number 3 now. In the next video, we'll do number 4. Tactic number 3, let's move on to that. Tactic number 3 is going to be to find a common denominator. Find a common denominator. So that'll be when you're adding fractions, of course. So let's use number 13 to help us demonstrate tactic number 3. This is number 13 on page 471 again. And let's see what the question is here. Sine theta plus cosine theta over cosine theta plus, we need cosine theta minus sine theta over sine theta. Okay, common denominator. Because we're adding fractions, so we've got to find a common denominator. So that would be what? We need a sine and a cosine. So our common denominator is actually going to be sine theta, cosine theta, one of both of them. So let's do this. Let's write sine theta plus cosine theta over cosine theta. We're going to need to multiply that one by a sine theta. You know what? I think I'm going to put it in the front. Since it's the monomial, let's put it up here. Sine theta, sine theta. I'm going to put parentheses around this part, this binomial part, to let me make sure I know. If I want to, I need to distribute that. Probably going to want to this time, but we'll see. So let's see, plus cosine theta minus sine theta over sine theta. To get this to have a common denominator, I'm going to need the cosine, multiply by cosine. So let's put that in the front as well. Cosine theta, cosine theta. So now we have a common denominator. They're both sine theta, cosine theta. So let's write that as our common denominator. Now that we've got it, we can use it. Sine theta, cosine theta. So I think I am going to distribute. Let's distribute as we go here. So we're going to have sine squared theta plus sine theta, cosine theta plus cosine squared theta minus sine theta, cosine theta. Okay, I bet there's some simplification we can do here. Let's look. Let's check out right here. Let me highlight it for you. See this plus sine theta and sine theta, cosine theta, and the minus the sine theta, cosine theta. That's going to actually go away. So that's nice. So we'll end up with sine squared theta plus cosine squared theta over sine theta, cosine theta. Now, hopefully you know I'm not able to cancel the sine and the cosine because of the addition on the top. But hey, look at your identity sheet. What do you notice? What do you notice about sine squared theta plus cosine squared theta? Well, that's the main one you need to have memorized. The main Pythagorean identity is that sine squared theta plus cosine squared theta equals 1. So this is 1 over sine theta, cosine theta. So that reduces all the way down. When I actually get common denominators, my original question there, number 13, reduces all the way down to 1 over sine theta, cosine theta. You try number 14 now by yourself, and then move on to tactics number 4 and 5 in the next video.